Hello, Middle 3. Today we will know about a new branch in mathematics called trigonometry. This branch is talking about triangles and the relations between its angles and its side lengths. By using this science, we can treat with triangles either by geometry or by trigonometry. But first, we should know that we have three main ratios in trigonometry. These three ratios are sine, cosine, and tangent. And we can write them mathematically as sine, cosine, and tan. So now we are talking about these three ratios: sine, cosine, and tan. So let's see what every one of them means. If we have a right angle triangle ABC at B, so now I have AC called hypotenuse. So sine A, the sine, this ratio, is used for angle. So sine angle A. So I said sine A. Sine A equals the length of the opposite side of the angle A over the length of the hypotenuse of the square ABC. So again, when we are talking about sine, cosine, and tan, we are talking about a right angle triangle. So the first ratio, which is sine angle A, equals to the opposite side of the angle A over the hypotenuse of the triangle ABC. So the opposite side of the angle A is CV over the hypotenuse, which is AC. So sine A equals the length of BC over the length of AC. The second ratio we have is cosine A equals to the adjacent side of the angle A, which is AB, over the length of the hypotenuse of the square ABC, which is A, the length of AC. So cosine A equals AB over AC. And finally, tan angle A equals to the length of the opposite side of the angle A over the length of the adjacent side to angle A, BC over AP as side lengths. These three ratios are for angle A. So we can do the same thing to angle C. So when I want to calculate sine or cosine or tan for angle C, so I will see that cosine C equals to the opposite side over the hypotenuse. So cosine C equals to BC over AC. And sine angle C will be AB over AC, the opposite over the hypotenuse. And finally, tan C equals to the opposite side to angle C, which is AB, over the adjacent side to angle C, which is CB. Now, let's note that sine A equals cosine C. The both equals to BC over AC. Also, cosine A equals to sine C. The both equals to AB over AC. So Now, I can deduce that for any two complementary angles means two angles, the sum of them equals to 90 degrees. So, for any two complementary angles, like A and C, sine A equals to cosine C, and cosine C equals to sine A. Also, cosine A equals to sine C, and sine C equals to cosine A. The sine of one equals the cosine of the other one, and vice versa. Also, we can note that tan A and tan C both are the multiplicative inverse for each other. Tan A equals BC over AB, and tan C equals AB over BC. So tan E times tan C equals 1. Now, let's note something. If I want to divide sine A over cosine A, sine A equals to opposite side over the hypotenuse, divide cosine A, adjacent side over the hypotenuse, so the quotient will be opposite side over the adjacent side. What is the ratio which equals to opposite over adjacent? It's tan the angle. So I can say that tan A equals to sine A over cosine A. So now I have two ways to calculate tan any angle. Even if I have the side lengths of the triangle, right angle triangle, so the tan of the angle equal to the opposite side of this angle over the adjacent angle, over the adjacent side. Or I have the sine and cosine for this angle, so I can calculate the tan by dividing sine A over cosine A. Also, we have a remark, as we noted before, for any two complementary angles, A and C, sine A equals cosine C, cosine A equals to sine C, and finally, the multiplication of the tan of the two complementary angles will be equal to 1. Now, let's see some examples. Example 1. Here I have ABC is a right angle triangle at A. So when I see a right angle triangle, so it's allowed to me to use the ratios of trigonometry. Okay, where the length of AB equals 9 centimeter, the length of AC equals to 12 centimeter, and another, so I want to find sine B, cosine B, and tan B. So to find sine, cosine, tan, I must have the three lengths of the three sides of this triangle. So by using Pythagoras, I can easily calculate the hypotenuse length, which is CB. So CB equals to the square root of 12 square plus 9 square, and that will be 15 centimeters. So now I have the three side lengths of this right angle triangle, so easily I can calculate sine, cosine, tan for any angle of it. So sine B equals to opposite over hypotenuse, so 12 over 15 to be simplified to 4 over 5. And cosine B, which will be the adjacent over the hypotenuse for the angle B, so it's equal to 9 over 15 and to be simplified to 3 over 5. And finally, tan B will be opposite side over the adjacent side, so it will be 12 over 9 to be simplified to 4 over 3. So it's so easy, so direct. to calculate the ratios of any angle in a right angle triangle. The second request is to prove that sine B times cosine C plus cosine B times sine C equals to 1. So easily I can calculate every ratio and then substitute every ratio with a number and calculate the numerical value for this equation, and it will be right. So I have sine B and I have cosine B. Just I want to calculate cosine C and sine C. And here we have two ways. Even if I want to calculate cosine C and sine C, it's right, because I have the three lengths for these three sides of triangle ABC. Or I can set that sine B equals to cosine C, because B and C are two complementary angles. The two methods are right. So just pick one method and begin to prove. So I picked the second method and said B and C are two complementary angles, so sine B equals cosine C and cosine B equals to sine C. So sine B times cosine C equals to 4 over 5 times 4 over 5 plus cosine B times sine C will be 3 over 5 times 3 over 5, so that will be 16 over 25 plus 9 over 25. By adding these two fractions, it will be 25 over 25, which equals to 1. I think everything is crystal, everything is more easy than anyone can imagine. Now let's see another example. In this example, ABCD is a quadrilateral in which measure angle A equals to measure angle D equals to 90 degrees. And AD is parallel to BC. AD equals to 6 centimeter, AB equals to 8 centimeter, and the request is to find the length of DC. Now, to find the length of DC in a right angle triangle like DCB, the first method coming to my mind is by using Pythagoras. But to use Pythagoras, I must know the lengths of the two other sides, which is DB and CB. DB is easily to be calculated by Pythagoras from the small triangle ADB. So I can calculate the length of DB as it's the root of 6 square plus 8 square. So DB equals to 10 centimeter. Now in the triangle DBC, I have the length of DB 10 centimeter and I have no other data. I have no other length. So by Pythagoras, it can't be calculated, the length of CD. So I will directly go to trigonometry and use the trigonometry ratios to calculate the length of CD. But how can I calculate the length of CD by trigonometry? First, I must know that every given in this example is very important. And I have a given told me that AD parallel to BC. This given told me that measure angle ADB equals to measure angle DBC because they are two alternate angles. Measure angle ADB equals to measure angle DBC. So I will calculate tan angle ADB. tan angle ADB will be 8 over 6. So it's 4 over 3. And since measure angle ADB equals to measure angle DBC, so tan angle ADB equals to tan angle DBC. These are two equal angles, so tan ADB equals to tan DBC. Okay, tan angle ADB equals to 4 over 3. And tan angle DBC equals to what? Opposite over adjacent. It's equals to DC over DB. And I have the length of DB. So 4 over 3 equals to DC over 10. Crisscross. So I can calculate the length of DC equals to 4 times 10 over 3, which will be 13 and 1 over 3 centimeters. So easy questions. And so direct questions. We have 2 lessons in the unit of trigonometry. This is the first lesson of them. We have in our booklet some problems to be solved for this first lesson. I wish this lesson is easy and clear and there is nothing hard into it. Thank you very much. Waiting for you again in the second lesson in trigonometry. Thank you, middle 3, and goodbye.